Hey, grade. So today we're gonna talk about convection currents in our atmosphere. And first, we're gonna start talking about what is the atmosphere. It's the layer of air around the Earth, and it's divided into 5 different layers. And those layers are the troposphere, the stratosphere, the mesosphere, the thermosphere, and the exosphere. Air has both mass and volume. And when we think about what the atmosphere is actually comprised of or made up of, it's 20% oxygen, 78% nitrogen, and 2% argon and carbon dioxide. It's really important because it creates livable conditions, like in terms of temperature and water content in the air and on the Earth, and it protects us from radiation and meteoroids. Air pressure is the weight of the atmosphere pressing down on the Earth. As altitude or distance from sea level increases, air pressure will decrease. Low altitude equals high air pressure. High altitude equals low air pressure. When we think about the atmosphere and the convection currents that occur, they happen on 2 different scales, both local and global. Global winds occur because of the uneven heating of the Earth, and it's on a really large scale. Because of the uneven heating, the equator warms up much faster than the poles. The wind moves around the planet because of the differences that are causing air pressure, and they don't move straight up because the Earth spins on its axes. The curving of the winds is called the Coriolis effect, and this is what you see right here. Within each latitude zone, you'll notice that we have different types of winds coming in, and we have these convection currents happening in the troposphere, where the heat rises and the cool sinks. The 2 sets of each of the following global winds are trade winds, polar easterlies, and prevailing westerlies. There are also 2 really calm areas, and these are called the doldrums and the horse latitudes. And this is right around the equator. And then the horse latitudes are more closer to the poles. And you'll still notice these convection currents going on in the troposphere. If we talk about the local winds instead of the global winds, we're talking about land and sea breezes. And when you talk about land and sea breezes, you're talking about where the air is coming from. In the daytime, when the sun is up, the land heats up very quickly, and the air above it warms up a lot more than the air over the water. The warm air over the land is less dense and begins to rise, and low pressure is created. The air pressure over the water is higher with cold, dense air, which moves to occupy the space created over the land. The cool air that comes along is called the sea breeze. So where the direction the breeze is coming from, the origin of it, is how you say what type of breeze it is. So if the cold air is coming in from the sea, it's a sea breeze. In the nighttime, the reverse happens. The land really loses heat a lot faster, while the water will retain its warmth, which means that the air over the water is warmer, less dense, and begins to rise because it's warmer. Low pressure is created over the water. Cold, dense air over the land begins to move, and you end up with a land breeze. So if the breeze is coming from the land, it's called a land breeze because that is the origin of that breeze. And it looks something like this. Go ahead and move on to your packet for today. There's both practice and review questions for you to be working on.